you find the first derivative, you find the second derivative, and you build a chart like the one that you guys were filling the blanks in on. And once you fill the blanks in on a chart like that, then you can sketch the graph off of the information just like you did on that big chart on the front.
This is number 3 on the one you just gave us?
No.
It's on, yeah, it's on the very back page.
Which one is this?
Okay, so that is what graph analysis means. It means that you build a chart like the one that you guys spent time at the end of class on Tuesday filling out, and then you use the information in the chart to make your graph. And it starts by finding the first derivative and finding the second derivative, and then you find where those values are either 0 or undefined, and so forth, okay? So my first derivative, careful, this is cosine being plugged inside of a square. So the outside function is the square. Okay, so I'm doing the power rule. Remember, you leave the inside of your function the same. Okay, so I just did power rule. But then inside, so the derivative of the inside will be minus sine. And then here, this is just straightforward, -2 times cosine. And I will probably rewrite that with the negative out front here. Okay, so my second derivative, I need to do product rule here. So I have first times derivative of the second. Okay, so I left this one alone, and then I took the derivative of that, and the derivative of sine is cosine. And then I add the second one left alone times the derivative of the first one. So cosine's derivative is negative sine. So the negative from that will cancel this negative. So I will get 2 times sine of x. And that gives me 2 sine squared minus 2 cosine squared, which is 2. Yes?
I have a question about, after we did the first derivative, could we simplify the 2 cosine, sine, and negate the double angle formula, or no? That trick on the
Okay, well, hang on. The first derivative, we have 2 cosine, and the derivative of cosine was minus sine.
So that's 2 times cosine times sine, right?
This is 2 times cosine of sine. Yeah, you could write it as
Sine
2
2x.
sine of 2, yeah, it would be minus sine of 2x.
Would that change the result?
I don't, well, if they're equal, it shouldn't
It should
change
not.
the, I mean, you might get something that looks different, but provided an identity would be equal. I'm just trying to think if it would make it easier on us. I don't think,
Make much.
okay, here's why we don't want to do that in this case. Because this would then be written in terms of sine, this would still be written in terms of cosine, and one of the things we want to do is set it equal to 0 and solve. And so we'd have more, we'd actually have to rewrite it back like this so we could factor the cosine out.
So we have to reverse it instead, I got you.
Yeah, so John, it was good you thought of that, because there are times you want to do that, but for this particular, what we're doing here, it wouldn't benefit us. Now, down here, I was actually thinking about that, because this is actually, okay, the double angle formulas he's talking about, sine of 2x is equal to 2 times sine of x cosine of x. And cosine of 2x is equal to cosine squared x minus sine squared x. So this is the identity he was talking about here. And sometimes you might want to do that, but for what we're doing, it's not going to benefit us. But down here, do you see how that's the opposite of this? So you could rewrite this as minus 2 cosine
2x.
of 2x. And we do want to do that in this case because it makes it easier to solve the equation. Like when we set it equal to 0, it would make it easier. Okay, so this in itself is minus cosine of 2x, and then the 2 was from here. Okay, then once you get your first and second derivatives, you want to know the critical values. Technically, the critical values, a reminder about the definition of critical values is that it's values at which the first derivative is equal to 0 or the first derivative is undefined. When we're doing graph analysis, though, you also want to know where the second derivative is 0 or undefined. So again, if I were making up the vocabulary word, I would include the second derivative as part of critical values, because often, most problems, when you're interested in one set, you're kind of interested in the other set. But technically, the definition is where the first derivative is 0 or where the first derivative is undefined. So we want to find those, and then we also want to find where the second derivative is 0 or undefined. For the functions we have, we don't have to worry about the undefined because sine and cosine are both continuous functions. There are no values at which they're undefined. So our derivatives involve sine and cosine. And multiplying doesn't cause us any trouble. If we were dividing, we'd have to be careful not to divide by 0. But, you know, so by that quick analysis, all now I'm interested in is where they're 0. But for number 2 on your paper, notice you've got a denominator, so I can't, is there a square plus a square though?
No, it's a square plus 1.
Well, yeah, but 1 could be 1 squared.
Yeah.
So you might not have to worry about that undefined, but. Okay, so f prime of x set equal to 0 is going to give me the equation -2. I'm going to factor that -2 out, and I'm going to factor the cosine out. Okay, so I'm factoring out the -2 and the cosine, and I am left with a sine of x in the first factor and a +1 in the second factor. Okay, this times that gives me my first factor. This times 1 gives me my second term there. All right. So then -2 times cosine of x might be 0, or sine of x plus 1 might be 0. So this occurs. And you know what, I think I didn't give you bounds on it, but if we don't have bounds, that graph repeats over and over again. So let's just do the problem from 0 to 2 pi. Okay, but we're going to limit ourselves to just worry about from 0 to 2 pi. So cosine is 0 at pi over 2 and at 3 pi over 2. So I get 2 zeros from this factor in the interval from 0 to 2 pi, and then from this factor, sine of x would equal -1. That occurs at 5 pi over 4 and at 7 pi over 4. Okay, again, just a little review about the unit circle. Okay, so sine is telling you y coordinate, cosine is telling you x coordinate. So cosine is 0 at 90 degrees or pi over 2, or at 270, which is 3 pi over 2. And then sine is -1 down in quadrant 3 or in quadrant 4, and it's -1 at the 45 degree. So down here it'd be 225, so that's 5 pi over 4, and then 7 pi over 4 in quadrant 4. Okay, so those are my 4 critical values. And I also want to know where my second derivative is 0. So -2 cosine of 2x equals 0 when cosine of 2x equals 0. So 2x has to equal pi over 2 or 3 pi over 2. So that means x is either pi over 4 or it's 3 pi over 4. And, yeah, okay. So those are all of our values. I'm hesitating a minute because it seemed like I work out these problems because I do it a while ago, and then now it's been a while since I did it. And I thought I remembered getting pi over 6s, but I do lots of problems, so I could just be misremembering. But we had it is. I wrote down the original function correct, right? And this is the
Yeah,
function.
yeah, that's right, yeah.
So, okay. I guess I'm just remembering.
You don't take the second derivative of -2 cosine.
Ah, okay. Well, no, I think I did. Wait, hang on, okay, here's my 2 terms, right? So, we did our product rule. Okay, so this, yeah, that might be why my memory is. Hang on, let me erase here, because that would only affect our second derivative, right? Like our first derivative is okay, so 2 cosine of x, and then the derivative of cosine is negative sine, and the derivative of this would be -2 cosine, so that's all fine. Okay, so we did first derivative of the second plus the second times derivative of the first, and you are correct, Dustin. So we would get +2 sine of x. Yeah, okay, that's going to change our second derivative. So I still end up like this. Okay, we have -2 cosine squared plus 2 sine squared plus 2 sine of x. And technically we can still rewrite that using the identity here, but because we have that other term, that's not necessarily going to help us to have a cosine of 2x, because then we still have that sine of x. So I actually want to rewrite cosine as 1 minus sine squared. Sorry, cosine squared is 1 minus sine squared, because then everything will be written in terms of sine. So -2 plus 2 sine squared plus 2 more sine squared. So I get 4 sine squared x plus 2 sine of x minus 2. And that is what we want to set equal to 0. So let's see. both of these are from the first derivative, right? Yeah.
Yep.
Okay, I'll leave them up there. Okay, so over here, I'm just gonna use this little space over here. So 0 equals 4 sine squared x plus 2 sine of x minus 2. Whoops, I need an extra 2 there. Okay, then I have a quadratic form here. I can either use quadratic formula. I think this factors though nicely, so when it factors nicely, you're better off factoring. But if I put 2 times sine of x, and then I put another sine of x,
And then 1 and 1.
and then a positive 1 and a negative 1.
Yep.
Okay, so now if we look at these factors, 2 sine of x minus 1 equals 0, or sine of x plus 1 equals 0. I'm running out of room on the board. But this is going to ask me to find where sine of x equals a half. Because I added 1 and then divided by 2. And this is going to ask me where sine of x is equal to minus 1. So we're going to have some duplicate values here. And then we're going to get a couple new values in our set from here. Okay, so f double prime equaling 0 is going to give me pi over 6 and 5 pi over 6, and then we're still going to have 5 pi over 4 and 7 pi over 4 from, like, the solutions to that second factor are going to match these. Okay, and then these are from sine of x equal to a half. So sine's positive 1/2 at 30 degrees, which is pi over 6, or at 150 degrees, which is 5 pi over 6. Okay, so now we build our chart, and let me kind of stack our important information, because I'm going to need space on the board to build my chart. Although I guess I could build it on the Elmo thing over there. Okay, but in the long run, we're going to want our original function. So our original function is cosine squared x minus 2 sine of x. We're going to want our first derivative, and the first derivative is minus 2 cosine times sine minus 1, or no, plus 1. And our second derivative is, I guess I'll just use that form down there, 4 sine squared plus 2 sine minus 2. Okay, I want these handy because we're going to use them. We also want our critical values. So our critical values were pi over 2, 3 pi over 2, 5 pi over 4, 7 pi over 4, and pi over 6, and 5 pi over 6. Technically, these were the critical values because they made the first derivative 0. But our chart's also going to contain the other two. So what you do now is you build intervals like I did on that chart that was on that you guys filled in on the front page of this, and you skip from the beginning of your interval, we're going from 0 to 2 pi, and you account for each one of these values and in between each one of them. So my first interval is going to go from 0 to, the smallest of all these is the pi over 6. And then you'll account for what's going on at pi over 6. And then you'll go from pi over 6 to the next smallest value,
Pi over 4, no.
which is your pi over 2.
Yeah.
And then you're gonna go from pi over 2, whoops, sorry, I left off pi over 2 by itself. And this should actually be a parenthesis. Okay, so then we're gonna go from pi over 2, and the next one, okay, so pi over 6, pi over 2, 5 pi over 6, and then 5 pi over 6, and then, okay, so 5 pi over 6 is in quadrant 2,
5 pi over 2.
and then 5 pi over 4, okay, then I want to leave space, and we'll pick up over here. So then at 5 pi over 4, you'll account for that, and then you'll go from 5 pi over 4
3 pi over 2.
to 3 pi over 2, and then you'll account for 3 pi over 2, and then you'll go from 3 pi over 2 to 7 pi over 4, and 7 pi over 4, and then that was the last one, right?
Yeah.
And then you're going to 2 pi, and you're gonna stop at 2 pi. Okay, so these are my intervals of x, or my values of x. And I want information about the first derivative, or actually, I'll put it in order that is on your, I have the information about the function next, right? And then I have the first derivative. And then we're continuing the same chart over here, so.
Miss Moser?
Yes.
I don't feel too good. Can I turn in my project